Hello, everyone. Can you hear me good? All right, great. Thanks everybody for coming here, and hello everyone those who are online. My name is Salima. I'm from Singapore, so I flew all the way here just to be here. It's my first time on site. Usually I'm virtually behind the laptop, so pretty excited to be here. My topic is on leveraging AI for attacks. So a little bit of background about myself. I've been working in the cyberspace about 6 to 7 years now, and I started off in academia focusing on research on ICS and OT security. And after 3 years, I decided to join the corporate world, and I've been with Accenture ever since. So at Accenture, I'm doing threat intel work, mainly detecting and responding to emerging cyber threats. And recently, about 1 to 2 months, I'm in the DFIR team as a secondment. This is the outline we're going to walk through today. First, I'm going to look into what is AI. I'll be looking into some terminologies of AI because AI has been used a lot, but what do they actually mean? And then look into how AI is used in the cyberspace. And then look at the main meat of this topic, which is creating an AI attacker or an AI attack tool. We look into how to build a model, how do we generate attacks by attack creation, and finally launching of this attack. And then look into one example, some use cases and challenges. So what is AI, machine learning, or deep learning? These words are used interchangeably. In fact, I will be using these words interchangeably throughout this presentation as well. But what do they actually mean? This is a screenshot that I took from Singapore Computer Society, which I think perfectly explains what these are. So overall, we have artificial intelligence. This is basically the development of smart systems and machines without the use of to leverage human intelligence. Secondly, the subfield, we have machine learning. This focuses mainly on creating algorithms from data to predict, to help you in any prediction from the data. And thirdly, deep learning, which is a subfield of machine learning. This focuses mainly on artificial neural networks. And then we also have generative AI, which I'll put it at the bottom. So what it basically means is it's capable of generating new attacks based on input data. And these are your ChatGPT, deepfakes, AI images, so on. But new attacks are not really limited to words, audio. Sorry, new content are not really limited to words, audio, pictures, but it can also be a text itself, which is what we'll be looking into today. Here are some examples on how AI is used in cybersecurity. So for the defense side, we're seeing a lot of anomaly detections. So AI models can help to analyze network traffic to identify unusual patterns that may indicate a breach. Secondly, we are also seeing used in threat intelligence. So AI tools can help to aggregate and analyze a large amount of data from various sources to to increase detect and response times. For the offensive side, we're seeing some automated phishing attacks. So AI algorithm can analyze social media to craft personalized messages just to have a likelihood of attack success. And also AI-driven malware like DeepLocker. It uses AI to adapt its behavior based on the environment itself. Let's look at some use cases for leveraging AI for the offensive side. Since we're in a hacking conference, let's just look at the offensive side. It could be used in automated recon. It could be used in evasion. It could be used for data manipulation, which is what we'll be touching on today. And it could also be used for autonomous malware, where it could just dynamically adjust its attack strategies. All right, now let's look into the main topic of this presentation, which is creating an AI attacker or an AI attack tool. Some background of this research. So this research is actually quite an old research of mine. It's about more than 3 years, in fact. This was when I was doing postgrad back in SUTD, Singapore University of Technological and Design. So shout out to my Prof. Aditya and Dr. Gautam for their input in this work. And during that time, I was working in academia, and one of the things that I was doing day in, day out was creating attack vectors for ICS systems. So I was coming out with different attack scenarios, launching attack from different layers of the network, coming out with different attacks and so on. And I just started wondering, why can't I just build something to give me all the attacks instead of coming in one by one. So I start thinking about how I should go about it. And just so happened, during postgrad, I was picking up machine learning module. And that gave me an idea. Maybe this is something that I could leverage on to build something that could give out a text to me instead of me coming out of different scenarios. And with that, this is what I came out with, called Anomaly. So this is a framework or methodology to create a AI attacker. There are three phases to it. First is the prediction model. Second is the attack creation. And third is the attack launcher. So throughout this presentation, I will go through all of these phases. This methodology is not only for ICS system, it could be used for any system, but just so happened that I was working on ICS system. So it's focused more on attacking ICS for this presentation. This research is conducted in a test bed called SWOT, or Secure Water Treatment Test Bed. So this test bed consists of actual treatment processes with plants, actuators, valves, PLCs to play with, like you can see in those photos up here. So to create an attack tool, first we need is data set. So you can train the model. And it could be any kind of data set. It could be network data, historian data, and so on. But I use historian data. So those who are not familiar with it, it's taken from a historian server in an ICS system. This data consists of all the values of component in the plan across all the timestamps. Okay, now let's look into building a prediction model. So the first step is to have interdependency of actuators from design knowledge. And then these are your inputs. So to build a model, you usually need some kind of input, and then you build a model and it produce some output. For this case, we are focusing on ICS system. Let's zoom in further into just launching attack on tanks, since it's easier to explain and understand. So the output in this case is going to be predicting of water level tank sensors. So the interdependency of actuators could be your valves and pump and so on. So from your interdependency of actuators, whatever you input into the model, and then the output will be your level sensor. So to explain further, let's see at the diagram below. This diagram is a short segment of the whole water treatment. So it consists of pump 6, valve 1, tank 1, pump 1, valve 2. Valve 1 is responsible for adding water to tank 1. Pump 1 is responsible for pumping out water out of tank 1. Pump 6, or N-1, just so happened that the test bed as used had pump 6. But it basically means any pump coming before the tank 1, in this case it's just 6, is responsible for adding water into tank 1. So when I say interdependency of tank 1, what I mean is pump 6, valve 1, and pump 1. If you want to build a model solely based on one process, it would just be pump 1, valve 1, and tank 1. But to have a more comprehensive model, it would be pump 1, valve 1, and pump 6. Now that you have the interdependency, the inputs, you build a model. I'm not going to tell you how to build a deep learning model, because there are a lot of good resources online you can find. But to simply put, I used TensorFlow with Keras and sklearn. So before we look into attack scenarios, before we look into attack creations, these are two possible scenarios that you could put an attack on a tank. One is to overflow the tank, and the other is to empty out the tank. So there are a few ways to overflow the tank. Based on the diagram that I shared earlier from the process, one way is we could turn on the valve, turn off pump 1. This will cause the water level to slowly rise up, reaches the brim, overspill, and possibly flood. Secondly, you could turn on pump 6, turn on valve 1, close pump 1. This will cause the water to slowly rise up, increase, and eventually overflow. And thirdly, it just focuses on pump itself. You turn on pump 6, turn off pump 1. This causes water level to slowly increase, reaches the brim, and eventually overflows. So these are the 3 possible scenarios that you could do to overflow a particular tank. And then another scenario is emptying out the tank. So simply put, it's basically cutting off water supply that's coming into the tank and pumping out whatever's that's inside the tank. So for in this case, you can turn on pump 6, turn on valve 1, and turn on pump 6, turn off pump valve 1, and turn on pump 1. This causes the water level in the tank to be pumped out, and eventually it will be empty. And eventually, the pump will be just pumping out air, and which will cause other consequences. Right, let's look at the attack. Now we know what's the possible scenarios for tank. Let's look at the attack creation. So first is to find what are the possible combination can be used or possible values to be used to load it into the tank or load it into the model. So these are, you will say like, okay, for this instance, you need to turn on pump 1, or for this instance, you need to turn on pump 6. We don't know what this is. So what this model does is all the possible combinations, you load it into the model, and then you'll pick up the best combination to use. So it will say, at this point, you should use 0, 0, 0, or on, off, which I will explain later on. And once you have the best combination, and once you have the best combination, you can use it to find how long the attack should be carried out. So let's say my target is to make the tank, let's say 300. Then from the possible combination from the best combination, it will tell you launch this attack for X seconds to reach your target value. Let's look into possible combination closely. So we know that attacks are created from interdependency of actuators of tank 1. So you can look, the interdependencies are listed on the table below, pump 1, valve 1, pump 6. To find the possible combination, the best combination, I use a search algorithm could be used. I use grid search algorithm, which is basically like a brute force, but I do not recommend using grid search if you have a large data to play with. In this case, it's okay. If you have a larger data, you should use like random search or Bayesian optimization algorithm. So all these inputs are then loaded into the prediction model. And the model will then tells you which is the best combination to use to launch the attack, instead of me coming out by itself. Another thing that I want to do for this attack is I didn't want to create any attacks. I want to create attacks that will launch at the most vulnerable state to cause the most damage. So I start thinking, what is the most vulnerable state of a state system or a state plant? So in terms of water tanks, if you can look at the line in purple, these are your upper and lower bounds. So under normal operation, it will just stay within this just stay within these 2 lines. It wouldn't go beyond this or above this. But if an attack was launched at, let's say, just below 500, it will cause a more damage compared to an attack was, say, launched at somewhere 600. So hence, I wanted to find what was the most vulnerable state to launch the attack itself. And then we have the target value. So if your objective is to overflow a said tank, the target value should be very high. And if your objective is to empty out the tank, the target value should be low or even negative. So this is the outflow. Once you list out all the possible combination, you load it into the prediction model, which you found out in phase 1. This will output the best combination to use. And for the best combination, based on your objective, it will tell you how long this attack should be carried out. Okay, let's look at the screenshot below. There's some few things happening here. So you can look at current value of LIT 101, which basically means tank 1, vulnerable state. So what this means is it's currently at the vulnerable state, which is at 816 level. And then you look below, this is your grid search algorithm or your search algorithm. You can see 000, 001, 010. These are the possible combination. And from that combination, it will tell you what is the predicted value of the said tank, which is why it's under predicted underscore LIT 101. So the first one is 000. Predicted LIT 101 is 816, which makes sense because nothing is being changed from the current value. But if you look at row 4, you can see that when it's 010, 011, you can see that the predicted value is at 817. So for this case, the objective is to increase the water level in the tank. And this will be the best combination to use. So what this model is trying to say is that when the water level is 816, the best combination to use is 011. And the predicted value will be at 817. So to put it in diagram form, what the model is telling you now is you turn on turn on pump 6, turn on valve 1, and close pump 1. This will cause the water level to slowly increase and eventually overflow. And based on the target, depending what the target is, in this case, it's mentioning that the attack should be carried out at 2 to 5 seconds. And now you know that the prediction model and then the attack scenario and the possible attacks that can be generated from the model. We need to find a way to launch this attack. So it could be any way to attack. There are a few ways to attack under like ICS systems. You could use exploit into a workstation and attack it via GUI. Another one is you could just attack directly on PLC code. You can do attacks on man in the middle and packet injection. So this is what I use. I injected packet directly to the PLCs to change the data. All right, so now let's let's look at some example of attack. This model generated a lot of attacks for me, but I'm just gonna show one example, which is emptying out tank 1 using pump 1, pump 6, and valve 1. So this is what we went through earlier. So the one on my right is the normal operation, and the one on the left is when attack is launched. So if you look properly, you can see that the graph started off straight, and it slowly dips, and then it goes up again, and then it drastically drop, and then it goes up again. And if you look at the one on the left, it's just a zoom out version. It goes straight, slowly dips, goes up, and drastically drop. And then you see a line in red. This is where I launched my attack, which is at the most vulnerable state. So under normal operation, at this particular tank, when it reaches below 600, pump 1 starts to turn off so that it prevents water from being pumped out. But what this model or the attack did was it continued to turn on pump 1 to cause more water to be pumped out of this tank. So this attack was stopped at 300, as you can see. So the water level now is below the normal healthy range. When this attack was carried out, there were some cascading effects that happened. So when the water is pumped out, where does the water go? It should go somewhere eventually. And what happened is the water being pumped went to the subsequent stages, and the subsequent stages test began to rise and was very dangerously high. So let's look at the cascading effect of this said tank. This is under normal operation. So normal operation, we have stage 1, which is N, which contains of valve 1, tank 1, pump 1. Then we have stage 2, which consists of valve 2 and some chemicals for pre-treatment of the water. And then stage 3 consists of tank 3 and pump 3. And then we have stage 6, N-1, in this case is just 6. It consists of pump 6. So this is what it looks like under normal healthy operation. So when the attack is launched using the AI model or the AI attacker, this is what we observe. We see that the model tells us to just turn off pump 6, turn on valve 1, and turn on pump 1. This causes the water level to slowly decrease, and eventually it becomes dangerously low. When pump 1 is on, valve 2 should be on. If pump 1 is on and valve 2 is switched off, it will cause the pipe to burst. We do not want that. This is one attack you could do on a system, but this is not the focus of this attack. So when pump 1 is turned on, valve 2 turned on, and what happens is all the water that's pumped out from tank 1, it goes to tank 3. So tank 3 reaches dangerously high all the way. And eventually what happens is pump 3 starts to turn on. This is because it wants to pump out all the water that's being pumped out of this tank. And this caused another cascading effect down the stream. So just because of one small attack, it caused a cascading effect for all different stages of the plant. Now let's look at some examples that you might face and some that I face. For this particular research, or any research relating to machine learning or deep learning, you need a good data set to build your model. If you don't have a good data set, it's pretty hard to work with. You could either collect your data or you could use a data set. I use the SWOT data set, which consists of normal plant operation for up to 3 to 4 hours without any attacks being launched. Secondly is the accuracy of model. So we know that a lot of deep learning models tend to have a lot of false positive. So we need to keep fine tuning it to find the sweet spot to make sure that it doesn't create a lot of false positive. Third is search algorithms. So in my case, I use grid search algorithms, which is like a brute force. And I mentioned do not use grid search if you have a large number of components to play with. So others you could use is random search and Bayesian optimization, for example. And fourthly, this is what that I struggle with during the research is discrepancy of attack duration. So as launching the attack, I realized that the actual attack was faster than the predicted model or the AI attack. And there were times I was like, Salima, you need to switch off this attack now. It's going to cause too much damage. So there are times where I have manually override this AI attacker or the AI attack tool so that it don't cause too much damage to the system. So I wouldn't say this is like a huge deal because you could fine tune it to have the exact number of attack to be carried out or the exact duration to carry out. So like say the actual attack it took like 30 seconds, but the model said do it in 60 seconds. So you just need some fine tuning to be done. And here are some use cases you could use for this AI attacker framework or methodology. I call this anom-D. Anom-D for anomaly, D for detection, E for evaluator. Because this is one part of my postgrad research. Another part was to use these attacks to evaluate defense mechanisms. Hence, I call it anom-D. Some use cases include you can launch attack on test beds to evaluate detector effectiveness, which is what I did. Other ways you could use it to launch attack on design phase to access design vulnerabilities early on. Thirdly, you could use it to launch attack on digital twin. So you could simulate real-world testing scenarios, and that's one way you could test it out. Fourthly, you could use it to create attack data set. And fifth is you could attack directly on detectors. So you pump in all the values and see how this defense mechanism responds. So now that we look into this kind of attacks is possible, how do we protect against them? One thing that I noticed is purely machine learning based defense mechanism do not work that well because the attack I launched based on the model was very subtle. It was decreasing very, very slowly, like -1, -1, -1 based on the model itself. Hence, there isn't any huge spike where where any machine learning detectors pick it up. But rule-based models, what I noticed is, let's say the rule is when the tank value is at say 300. So it doesn't matter if the attack is like slowly being doesn't matter if the attack is slowly being carried out. Once it reaches the water level below 300, it will just trigger an alarm. So it could be like 302, 301, 300, trigger an alarm. So that is what I noticed. Secondly, to protect this kind of attacks is to use multi-layers. This could be multi-layer defense mechanism, so you catch what that is missing on the other detectors, or also multi-layers in terms of network. So it could be different layer of network to find any discrepancy of reading in the data. And with that, we have come to this end of the presentation. So this research started off as just me wanted to automate some of my work that I do in work to instead of coming up with different scenarios, I wanted to build something where it just tell me what to do instead of me come up with it. And I used AI to try to figure this out. Honestly, going into this, I wasn't sure it's gonna be successful, but I was just curious. I was like, okay, let's just give it a shot and see how it works. And it turns out I actually managed to do some very good attacks just from this model. And overall, I say it's a successful research and it's a very good POC. It has a lot of room to grow. Yeah. That's all I have for my talk. If you have any questions, let me know. Yeah, this talk hasn't been published. Sorry, this presentation or content hasn't been published yet. So feel free to ask me any questions on it. Thank you.